Hello students, today we'll discuss IB Physics HL Paper 1, May 2019, Time Zone 1. In this paper you should not use, no calculator is permitted. My name is Nariman Maalim. Here you can see my mobile and email. I'm located in Baku. In the upper panel we will have questions, in the lower panel we will have solutions. So here are the sources that you should use to prepare for the exam. I recommend you to have physics data booklet with formulas. Here is the cover page. And here is the first question. A student is verifying the equation. The percentage uncertainties are, and what is the percentage uncertainty in X? So to calculate X, we are multiplying and dividing variables lambda, y, and z. 2 is constant and it is not approximated, so it doesn't affect uncertainty. Here we have the solution. So formula 1, 2. So we should add all uncertainties. So we add all uncertainties. Then we approximate uncertainties to two significant figures and we get 15%. So 15% is choice B. Question 2. A student models the relationship between the pressure of a gas and its temperature as P equals X plus Y T. The units of pressure are Pascal and the units of temperature are Kelvin. What are the fundamental SI units of X and Y? So this is the equation that we have. So X should be have the same units as P. So we write one equation for units. And P should have the same equation as YT. We have, out of this we have, and Y should have the same units as P over T. Then we find, so X should have units of pressure, and units of pressure, force over area, MA over area, kilogram meter per second squared, meter squared. So we get base unit for X, which is the same as for pressure. And for Y it will be pressure by temperature. So we divide this unit by Kelvin. And the choice is A. Next question. Question 3. A skydiver is falling at terminal speed when she opens her parachute. What are the direction of the velocity vector and direction of her acceleration vector before she reaches the new terminal speed? When she opens parachute, drag force increases dramatically, becomes greater than weight. Resultant force will be drag minus weight upwards, and acceleration according to second Newton's law also will be upwards. And it speeds up or goes at constant velocity. Velocity is always downwards. So we choose choice C. Direction of velocity downwards, direction of acceleration upwards. A sports car is accelerating from 0 to 100 km per hour in 3 seconds. What is the acceleration of the car? Formula for acceleration: change of velocity by time. Change of velocity, we change from kilometers, so kilometer is 1000, hour is 3600, and we should divide this by time, by 3. So after division we get this value, and this value should be in terms of G, so we divide by G. And we get approximately 0.9 G, so answer C. Next question, question 5. A girl throws an object horizontally at t equals 0. A resistance can be ignored. At time 0.5, the object travels horizontally a distance x in meters. and it falls through a distance y in meters. What is the initial velocity of the object and vertical distance after 10 seconds? So this is how it moves along parabola, x at constant velocity and y with constant acceleration. So when it moves along y depends on time as a square. So y at 1 second, after 1 second, divided y after 0.4 seconds will be equal to 4, because time is 2 times, so square makes 4. So y2 will be 4y1 second. 1 second. Horizontally it moves at constant speed, so if we divide, x equals ut when we divide x at 1 second by x at 0.5 seconds, time is increased 2 times, so factor is 2. So we choose answer D, 2 and 4, 2x and 4y. Next question, 6. An object of mass m is sliding down a ramp at constant speed. During the motion, it travels a distance x along the ramp and falls through a vertical distance h. The coefficient of dynamic friction between the ramp and the object is μ. What is the total energy transferred into thermal energy when the object travels distance x? As we have constant velocity, kinetic energy doesn't change, but potential energy decreases by mgh. So all this decrease turns into, according to conservation of energy, all this decrease of potential energy is equal to the heat. So mgh, choice A. Let us see what we have here. A weight carrying a tray is accelerating to the right as shown in the image. What is the free body diagram of the forces acting on the tray? So this is the picture. So on the tray we have two forces, weight and normal reaction. Normal reaction will be at 90 degrees. So I copied these forces over here. So we have two forces, weight and normal reaction. So two forces are C and D, and if we add two forces, resultant force in D will be to the right. So acceleration is to the right, so resultant force should also be to the right, and here a bit tilted, so we choose D. Question 8. Energy is transferred to water in a flask at the rate P. The water reaches boiling point and then P is increased. What are the changes in temperature of the water and the rate of vaporization of the water after the change? Temperature of boiling is fixed, so it is constant. So Q equals Lm, mass melted equals Q over L. Mass not melted, boiled, let's say it is boiled, equals Q over L. And rate of vaporization is delta M by delta T, delta Q over delta T by L. Delta Q over delta T is P, so greater rate of providing heat, greater rate of vaporization. So we choose answer D. Stays the same, increases. Question 9. An insulated tube is filled with a large number n of lead spheres, each of mass m. The tube is inverted s times so that the sphere completely falls through an average distance L each time. The temperature of the spheres is measured before and after the inversion, and the resultant change temperature is delta T. What is the specific heat capacity of the lead? So this is the picture. Now, how we can calculate? Right. So when we turn it upside down, we increase potential energy, and then it falls, potential energy change into heat. Temperature rises, so this means that heat Q was provided to mass Nm, specific heat is C, and delta T is the temperature. This heat comes from change of potential energy S times mgh, mass is Nm, S times, right, so these heats are equal, so we Q and Q equals, so these expressions are equal, so we rewrite this expression, and for C we get CGL over delta T, which is B. Question 10. A gas storage tank of fixed volume contains n molecules of an ideal gas at temperature T. The pressure at Kelvin temperature T is 20 megapascal. N over 4 molecules are removed and the temperature changed to 2T. What is the new pressure of the gas? So we use gas equation, write it in terms of number of molecules, then write formula for pressure. And in this formula we have separately NT, and R and Avogadro and volume are constant. So what is changing? Number of molecules and temperature. So we have case 2 and case 1. So if we divide pressure of case 2 by pressure of case 1, this common part we can cancel, and we get N2T2 by N1T1. So N decrease, and we remove N over 4, was 3 over 4 is remained. Temperature changed to 2T. Temperature increased 2 times. 3, 4 by 2 give us 3, 2. So ratio is 3, 2 of previous pressure, which is 30 megapascal. So we use C. Answer choice C. Question 11. A particle performs simple harmonic motion, SHM. What is the phase difference between the displacement and acceleration of the particle? So here we have picture, and from this picture we can see that when amplitude is positive, displacement is positive, acceleration is negative maximum. When acceleration is negative, displacement is negative maximum, acceleration is positive maximum. So this is method 1. We see that they are in anti-phase, so it means that phase difference is P. Method 2 is using formulas x equals x sine omega t, then A equals minus, which is phase difference pi. 12. Which graph shows the variation with time of kinetic energy of objects undergoing simple harmonic motion of period t? So energy is always positive. This is why we exclude A and B, and we look at these two graphs. If again we redraw this picture, we see that kinetic energy goes from 0 to maximum, then to 0, then again maximum over period. So it reaches maximum 2 times over period. So this is picture D. So we choose D. Question 13. A glass block of refractive index 1.5 is immersed in a tank filled with liquid of higher refractive index. Light is incident of the base of the glass block, which is the correct diagram for rays incident of glass block at an angle greater than the critical. So, greater than the critical, and we go from more dense into less dense. So, picture D is correct because we should observe total internal reflection, no refracted into the glass block. So we choose D. So more dense at angle greater than critical, no, so total internal reflection takes place. In an experiment to determine the speed of sound in air, a tube that is open at the top is filled with water and a vibrating tune fork is held over the tube as the water is released through the valve. An increase in intensity in the sound is heard for the first time when air column is X. The next increase is heard when the column is Y. Which expressions are approximately correct for wavelengths of the sound? So, and here we have three expressions. I copied this picture here. So when we observed first resonance, the frequency of tuning fork is equal to the frequency of the standing wave at depth x, ear column at depth x. This corresponds to the expression x equals lambda over 4 because naught until naught give us lambda over 4, lambda equals 4x. Next resonance will take place when we have the following antinode, node, and node. This corresponds to lambda over 2 plus lambda over 4 equals y. And we have another expression for lambda. From this we conclude that 1 and 3 are correct. So we choose B. 1 and 3 are correct. Charge flows through a liquid. The charge flows is made up of positive and negative ions in 1 second. 0.10 coulomb of negative flow in one direction and 0.10 of positive flows in opposite direction. What is the magnitude of electric current flowing through the liquid? Negative charge in opposite direction is the same as positive charge in forward direction, so total positive charge passed will be these two charges added. Because it is in 1 second, we turn it into amperes by dividing by time. Charge by time give us current. So we choose choice D, 0.20. Two parallel plates are at distance apart with potential difference between them. A point charge moves from negatively charged plate to the positively charged plate. The charge gains kinetic energy W. The distance between the plates is double as the potential difference between them is halved. What is the kinetic energy gained by an identical charge moving between these plates? So energy and work will be potential difference multiplied by charge. There is no distance here. And if we increase voltage 2 times, kinetic energy, we decrease voltage 2 times, distance double, potential even between half. So potential difference is decreased 2 times, kinetic energy decreased 2 times, and the relation is W over 2A. 17. A resistor of resistance R is connected to a fully charged cell of negligible internal resistance. A constant power is dissipated in the resistance the cell is discharged in time t. An identical cell is connected in series with two identical resistors, each of resistance R. What is the power dissipated in each resistor and the time taken to discharge the cell? So energy of the cell we can find by multiplying power by time from the first case. In the second case, this energy is dissipated equally in two resistors in series, so in each resistor energy will be Pt over 2. By trying to find energy dissipated in each resistor, multiplying power by time, we try to find where it is Pt over 2, and it appears to be only in B, so we choose B. Two currents, 3 amperes and 1 ampere, are established in the same direction through two parallel straight wires R and S. What is correct about the magnetic forces acting on each wire? So first of all, we should find direction of magnetic field by right-hand grip rule, and then from Fleming's left-hand rule we can find direction of force. So first finger along field, second along conventional current, then this will be the push, the thrust. Using these two rules, we see that, for example, circular magnetic field created by left wire current is anti-clockwise. It means that magnetic field is into paper, and Fleming's left-hand rule gives us attraction. According to 3rd Newton's law, the same force acts on left current from first current. So let's see what we have. Both wires exist equal magnitude, attractive force on each other. Yes, A. A horizontal electrical cable carries a steady current out of page. The Earth's magnetic field exerts a force on the cable. Which arrow shows the direction of the force on the cable due to the Earth's magnetic field? So again, Fleming's left-hand rule. Fold all fingers, then open first finger and direct it towards the Earth's magnetic field, tilt it. Then open second finger and point it towards you from page, then you will get B. So choice is B. 20. Some questions are very easy, some questions are very difficult, extremely difficult. For example, next question is very easy, just using formula. Satellite X orbit a planet with orbital radius. Satellite Y orbits a planet with orbital radius 2r. Satellites have the same mass. What is the ratio centripetal acceleration? Centripetal acceleration. Centripetal acceleration is created by gravitational force. So gravitational force is given by this formula. Acceleration is force over mass, so no mass. And if we write expression of acceleration at y, then we can change radius to 2r, radius of planet X, and 1/4 expression for acceleration for radius r, or ax. So ax equals 4ai, so ratio is, here be accurate, what you divide, so you'll get 4d. Next question is either extremely difficult or extremely easy. A motorist is cornering on a curved trace track. Which combination of change of banking angle theta and coefficient of friction mu between the tires and road allows the motorcycle to run around the cone at greater speed. And then we have increase or decrease coefficient and banking distance. I copied this picture here. So first of all, what we know? We know that centripetal force gives us this expression for velocity. Velocity is directly proportional to centripetal force. So centripetal force consists of two parts, banking and friction. Of course, method 1 easy, without deep theory, more angle, more banking force, more mu, more friction. Method 2 is partly theoretical. So if we consider this picture, we see that we have two forces from the road, normal force and friction force. Friction force is, normal force is at 90 degrees, friction force is along surface, here downward because we need centripetal force. So geometry tells us that a vertical component of normal force is, first of all, balanced by mg. So mg equals n cosine theta, and centripetal force is n sine theta. Friction force depends on reaction, mu mg over cosine theta, and actually the force to the center will be mu g mg. Friction is also slightly increasing the normal reaction. Here is what I found. So mg equals n cosine theta, it means n equals mg over cosine theta. And that's a more strict consideration is given here, so you can look through. So we have different forces, horizontal, vertical components, and after balancing we have this function. If we divide by cosine, we get tangent theta here, tangent theta here. Increasing angle will increase numerator, decrease denominator, so perfect. But it is, I don't know, is this what examiner expect, or is examiner expect method 2 or examiner expect method 1? I don't know. I think this question is inappropriate for this exam. Next question requires some tricks. I'll tell you which tricks. The diagram 22. The diagram shows an emission spectra of an atom. Increasing wavelength, it means that energy increase in opposite direction. Which of the following atomic level models can produce this spectra? So here I have two methods again. Method 1, give your own values. So for example, these are approximately equal, 5, 5, 20. As a result, you have the following possible emission, transition down or emission. And you see that some values are close, and this gives us the picture. High energy, then double line, then another after big break, another close energy. So it corresponds to A, picture A. So I use picture A. Method 2, find the greatest energy, middle line, and then the smallest line, and draw picture without numbers. That is more difficult, more smart, let's say, but we get again the same combination of transitions. Let me show you. Transitions and corresponding lines. Done. 23. The carbon isotope is radioactive. In the case according to the equation, what are X and Y? So here we have choices. beta particle, positron, and neutrino and antineutrino. Let's see what we will get. So top and bottom values should be balanced. From this we conclude that A and B are 0, because nuclear number can be 0 or more than or 1 or integer numbers. C and plus D equals minus 1. So one of these values is minus 1. It is beta particle. Beta particle is lepton. So accompanying lepton should be antiparticle to keep lepton number constant. So lepton number antineutrino has lepton number minus 1 because it is antiparticle. So here we have combination beta particle and with minus and antineutrino. So this is B. Questions 24. The rest mass of helium isotopes 3,2 helium is m. Which expression gives binding energy per nucleon? Binding energy is energy of splitting nucleon into separate nucleons per nucleon. Before splitting, total energy is mc squared. After splitting, total energy is 2 proton at rest, 1 neutron at rest, c squared. And difference divided by number of nucleons 3 give us choice B, 25. That's a very easy question. Most power stations rely on a turbine and a generator to produce electrical energy. Which power station works on different principles? In solar, light energy straight into electrical without using turbine or generator. 26. A beaker contains 1 kg of water at room temperature, is heated on a 400-watt hot plate. The specific heat capacity of water is shown. The temperature of the water increases until it reaches the contact value, and then it's removed from the hot plate. What will be initial rate of change of temperature? So Q equals Cm delta T. A rate of change of delta T will be Q by delta T, the rate of change of temperature. Q over delta T is power. Rewriting for gradient for initial rate of temperature, we get P over Cm. Cm we can put in the brackets. Then we put value and we get 0.1. Choice C, 27. That's a very strange question. In science, models are extensively used to study real-life situations. A person X on the beach wants to reach a person Y in the sea in the shortest possible time. The speed of person X on land is different from speed of person X in water. Which physical phenomena will best model the path with the least time? I don't know, is it least time or not least time? The path resembles mirror refraction. So I choose refraction. The 4 pendulums shown have been cut from the same uniform sheet of board. They are attached to the ceiling with string of equal length. Which pendulum has the shortest period? So I copied this picture here, and what I found that centers of masses are different. Here it is in the middle, here lower than middle line, and here above. Highest position of center of mass, and hence length of smallest length of pendulum and period is choice D. Shortest period. Choice D. Right. 29. Extremely easy. In Young's double-slit experiment, the distance between fringes is too small to be observed. What change would increase the distance between fringes? And we use formula and we change a bit different. Increasing the frequency, decrease wavelengths. Increasing distance, increasing the distance to the screen, yes. So we choose C. That is, I think, not easy question. The headlights of a car emit light of 400 nanometer and are separated by 1.2 meters. The headlights are viewed by an observer whose eyes has an aperture of 4.0 millimeters. The observer can just adjust the headlights as separate images. What is the distance between the observer and the headlights? I have drawn the picture, standard picture, and this is the formula. And from this formula we can find this distance x. So this distance, this angle theta is given in radian if you divide this distance in kilometers by x. Geometry tells us. On the other hand, it equals to 1.22 lambda over aperture. So putting values, we get 10 kilometers, 30. A transparent liquid film of refractive index 1.5 covers the outside of a glass lens of high refractive index. Liquid film is used to eliminate reflection from the lens at wavelength lambda in air. What is the minimum thickness of the liquid film coating and the phase change at the liquid glass interface? At denser material, phase change by P. So phase change here, glass is higher reflective index. So phase change is P here and P here, pi. No, P. Sorry, P. It means that so reflected ray has phase change pi, and the light that goes within the liquid also has phase change pi, but they should come in antiphase, so path difference should be lambda over 2. So path difference is 2Na, 2N, N is refractive index, T is thickness. This is a formula that they give. Path difference should be lambda over 2, and we get thickness lambda over 6. So we choose lambda over 6 and pi. So choice D. A negative charge Q is to be moved within an electric field E to equidistant points from its position as shown. Which path requires the most work? I copied this picture here. The work done is force by distance along the force. So the greater by magnitude distance along the force is for A and D, but because it is negative charge, we need force required should be to the right. And this is why for D we have positive work, and for A we have maximum by magnitude by negative work. So we choose D. Next question. The escape velocity of an object on the surface of Earth if V escapes. The diameter of Moon is 4 times smaller than the Earth, and the mass of Moon is 81 times smaller than that of Earth. What is the escape velocity of the object on the Moon? So section 10.2, escape velocity. On the Moon, we express everything mass of the moon in terms of mass of Earth, radius in terms of radius of Earth. Then we take factor 2,9 and we get expression for escape velocity on Earth. So we get 2/9 of escape on Earth. So it is C. Difficult question. A satellite in a circular orbit around Earth needs to reduce its orbital radius. What is the work done by a satellite rocket engine and the change in kinetic energy resulting from this shift in orbital height? Positive or negative? Let us see. Orbital velocity is given by this formula, inversely proportional to square of radius. At lower orbit, velocity and kinetic energy are greater. But what about total energy? Potential energy at distance r is given by this formula. Kinetic energy using orbital by this formula. Adding, we get this value. And what is interesting? The lower you go, the more negative energy you have total. It means that to go downward, a closer orbit total energy at lower is less. So we should do negative work to decrease total energy. So choice C, negative increase. Negative work should be done. That's easy question. The graph below shows the variation with time of magnetic flux through a coil. Which of the following is 3 times for which the magnitude of the induced EMF is maximum? So 11.1 induced EMF equals gradient rate of change of flux or gradient of this graph, and maximum gradient we have at point 0, t over 2, and t, here for example 0, here 0, but here maximum. So answer is B. Two capacitors of 3 microfarad and 6 microfarad are connected in series and charged using a 9-volt battery. What charge is stored on each capacitor? So method 1, equal charge on plates, so equal. Straightforward, you can choose A. Method 2, calculations, if you want. Total capacitances can be found from inverse formula, 2 microfarad. Charge is on all plates is the same, and it is C over V, so it is 18 microfarad, the same value. The circuit diagram shows a capacitor that is charged by a battery after a switch is connected to terminal X. The cell has EMF and internal resistance. After the switch is connected to terminal Y, the capacitor is charged. What is the nature of the current? The magnitude of the initial current in the resistor after the switch. Increasing, decreasing, and value. Of course it is decreasing because it is discharging, and the value is initial voltage on capacitor is V, so current will be V over R, so decreasing, so it is C. 38. A bit difficult. A metallic surface is first irradiated with infrared radiation, and photoelectrons are emitted from the surface. The infrared radiation is replaced by ultraviolet radiation of same intensity. What will be the change in kinetic energy and the rate at which the electron ejected? So this is a formula, section 12.1, kinetic energy HF minus work function, greater frequency, greater kinetic energy. But same intensity means that less electrons, as electrons has greater energy, less photons will be falling in the case of ultraviolet radiation, and less electrons. So we have choice A. Kinetic energy increase by rate of ejected photoelectrons decrease. 39. Oh, 39. Difficult question. Half-life of radioactive nuclide is 8 seconds. The initial activity of pure sample is 10,000 becquerel. What is the approximate activity of the sample after 4 seconds? So you see 4 seconds is half-life. So during half-life, activity decreased 2 times. So this is the formula. During half-life, which is 8 seconds, it is 1/2. But if it is 4, it is the same as 8 divided by 2, and divided by 2 means square root, so it means square root of 1/2, which is 2/14 approximately. So it means that activity after 4 seconds will be activity at the beginning and 10/14 of that, which is C, approximately C, 40. Easy. A particle is confined within a nucleus. What is the order of magnitude of the uncertainty in the momentum of the particle? So 12.1 section, Heisenberg relationships. Here we have size, uncertainty in size, uncertainty in momentum, and some constant. So solving it for uncertainty in momentum and taking into account the size of nucleus is of order 10⁻15, we get something about 10⁻20, so it is C. Paper is over. If you need more papers, write to my email. Thank you for your attention.